As well as the cabinet, the component I'm most proud of is the Switchbox controller, having designed, built and programmed it myself. So I'm devoting a whole video to it, the final in this trilogy. Here's a block diagram of the Switchbox controller. Note that the thick lines represent buses, and in the case of the analog section, they are 4-channel audio buses. The topmost two blocks select an analog source to send to a recorder or amplifier. The output from the JVC's preamplifier goes to the external 4BX and graphic equalizer units, then returns to a Switchbox input, which goes to the 4-channel volume control and thence to a frequency splitter. The splitter divides the audio into low and high bands for sending to the treble Onkyo amplifier and bass JVC amplifier. Another block handles the digital signals, which require only one wire each, even for DTS surround. As for the analog section, there are record and play source selectors and a record destination selector. The output from the record source selector goes to an SCMS defeat circuit. SCMS equals Serial Copy Management System, a copy protection scheme intended to limit digital copying to just one generation. But this will probably never be used now, since I've moved away from mini-discs since starting this Switchbox design. The central control for the Switchbox is a microcontroller, that is, a microprocessor with inbuilt peripherals, that handles all the selector signalling, commands from the front panel controls and liquid crystal display, and communications with the outside world, the touch PC and the miscellaneous drivers board, amongst others. Also within this module is an LED driver for the infrared LEDs that control the various components of my hi-fi system. From that block diagram came circuit diagrams for each of the modules, and then came printed circuit board layouts. Here's a photo of the bare printed circuit boards. The large board is the main, or mother, board, into which plug daughter boards for the front panel, the long skinny one, and for the optical digital devices and control signal sockets. After soldering all the components on, the assembled printed circuit boards look like this. Because the microcontroller has a pin pitch of only 0.5 mm, which is difficult to solder by hand without special equipment, I had my friends at Elf Electronics solder that chip and a few other surface mount ones to the main board. The 7 boards are then installed in an aluminium enclosure, a fairly fiddly process. Here's a view of the assembled unit looking towards the rear. Because of the number of analog RCA connectors required, 56, and the tediousness of crimping all those short cables to connector pins, I had the cable connector assemblies made by Ramsonics in Sydney. All I needed to do then was solder each cable end to its RCA connector and plug the 4-pin connectors into the main board headers. And viewing towards the front shows the rear of the front panel board. Finally, with the top cover fitted and the block diagram on the lid, so that in 10 years' time it will refresh my feeble memory about what the box does, we see the rear panel with its host of analog RCA, Toslink and control connectors. Crowded, isn't it? And then the front panel. For the rare occasions when the touch PC dies, it has happened once in the 10 years I've been running it 24/7, I programmed the Switchbox so that most of its functions can be controlled manually from its front panel. Here's a brief demo of just some of that capability. When not in a menu, the main control knob, which works via a quadrature encoder, changes the playback volume, more strictly attenuation, which is how I prefer to display it. But if you press the menu button, the LCD shows the top-level menu list, and the big knob allows you to scroll through the list of available submenus. When you find the one you want, just press the big knob in, and it selects that menu and displays the next level menu. Here, we're going to change the digital input selection. So scroll to the digital input you want, and again press the knob in. The Switchbox then signals the selector chips to turn off whatever was previously the input, and route that desired input to the amplifier. The exit button backs out of the menus. The Switchbox receives and decodes infrared commands from the remote control, and after working out what to do with them, sends out infrared commands to the equipment via infrared LEDs mounted in a nearby light fitting. So when I press a remote button that requires a remote command to in turn be sent to some equipment, the Switchbox sends that command to these LEDs, which is picked up by the desired equipment. Each different type of equipment uses different codes, so they only respond to a code intended for them. You knew that digital cameras respond to bright infrared light, didn't you? So your digital camera, including a phone camera, is a convenient way to quickly check if a remote control device is sending out infrared commands or not. The Switchbox and the Touch PC are connected by a serial cable, so that they can send commands and data to each other and reply. This connection also allows the touch PC to be used to reprogram the flash memory in the Switchbox. So after fixing a bug or adding a feature to the Switchbox firmware, I upload the new firmware file to the touch PC via the Wi-Fi network. Then, at the touch PC, I go into the Tools menu and press the Program Switchbox button. I then have to place the Switchbox into bootloader mode by pressing a particular sequence of its front panel buttons, which I do, then press the Proceed button on the touch PC. From there, the touch PC runs a boot loading routine, transferring the program to the Switchbox and then checking that it was successfully burned to the Switchbox's flash memory. This display is in real time. It doesn't take long, since the whole Switchbox firmware is only about 12 kilobytes. So that's the end of my hi-fi trilogy. I hope you've enjoyed watching it as much as I enjoyed making it.